Hello students, welcome in Babita science tutorial. Let's continue our chapter chemical reactions and equations. In the previous topic or previous video, I have explained many things or many topics related to this chapter, and in this video we will discuss about the displacement reactions, and this is our part 8 of chapter 1. Let's start on displacement reaction. First of all, displace means to remove. Displace. Okay, shift to another place. No, the displacement reaction is when one more powerful element, a most reactive element, can displace the least reactive element. That is called the displacement reactions. Means those reactions in which one element takes the place of another element in a compound are known as a displacement reactions. Students, this displacement reactions you can better understand if you have a complete knowledge of a reactivity series of a metals, because this displacement reaction is totally based on the reactivity series of a metal, and in the reactivity series of a metal we have already discussed about how the most reactive metal is placed on the top and the least reactive metal is present on the bottom. Means most reactive metals can displace very easily the least reactivity metal. Let's proceed now with the help of this activity 1.9. You can understand better what is the displacement reactions. Now see here in the activity 1.9, take 3 iron nails and clean them by rubbing with a sandpaper. I told you earlier also we can use the sandpaper to remove the dust particles of any substance. Take 2 test tube, mark as A and B in each test tube. Take about 10 ml of a copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the 2 iron nails from the copper sulfate. Compare the intensity of the blue color of a copper sulfate solution in test tube. Also, compare the color of the iron nails dipped in the copper sulfate solution with 1 capped aside. Now students, you can better understand with this diagram. See here we can take the 2 iron nail. First one, this one, and second one is this one. Iron nail taken out from the copper sulfate solution. When this one is a pure iron nail, and this one we can remove from the copper sulfate solution. So we can keep this 2 iron nail just for a comparison why the color of this iron nail is a change as compared to the first one. Now according to the activity, in the activity they want to say take the 2 test tube. No, this one is the first test tube and this one is the second test tube. In the first test tube you will in the both the test tube you will pour copper sulfate solution. Okay, copper sulfate solution means CuSO4. Now the color of the copper sulfate solution is a blue in color. No, this one we will use this first test tube just for a comparison. Now what you will do, you in the second test tube you will keep you will put this nail here, okay, in the second test tube, and you will leave for this nail here for 20 minutes. Okay, so what you will observe after 21 minutes, you will see that the color of this solution is a change. The color of the solution is here a light greenish in color. Then students, what's indicate here? Here again it can indicate that most powerful element can displace the least reactive metal. Now see here, with the help of this reactions you can better understand. Now here you will see, when this iron nails become a brownish in color and the blue color of the copper solution fades, the following chemical reaction takes place in this reactor. Now students, you see here, this one is a iron. Iron means iron nail, because this nail is made of the iron, that's why we can use the symbol here iron. Okay, and this iron nail is dipped in the copper sulfate solution. This iron nail is dipped in the which one? Copper sulfate solution. Now in the reactants, iron and copper sulfate is the present here, but you will see here in the product, here is a iron sulfate and the copper here. Now here color is a change here. Here you will see the iron sulfate or ferrous sulfate color is a change here. Here the solution will turn in the light green in color. Why students? Here you will see here, okay, when we see the reactivity series of a metal, okay, then you can just see the position of iron and the copper. Then iron is just above the copper. Iron is just above the copper. When we see the reactivity series, okay, I will write it again. See here the reactivity series here. I will not write all. I want to show only the zinc and position of the zinc and position of iron and copper in the reactivity series. Now starting from zinc here, Zn, okay, Fe, 10, Sn, lead, Pb, okay, hydrogen and copper is here. Now you will see here copper is here and iron is here. It means which one is the most reactive metal? Okay, because iron is just above the copper, that's why iron is a most reactive metal as compared to the copper. So from these reactions you will see here, in the iron plus copper sulfate, iron can easily displace the copper, because iron is a most reactive metal than the copper. Then it will give rise to ferrous sulfate plus copper. Means most reactive metal can displace the least reactive metal. That's why this reaction is known as the displacement reactions. Now student, I hope you will understand what is a displacement reactions very easily. In the displacement reaction, when the more powerful elements can displace the least reactive metals, that is called the displacement reactions. And you will see here color is also change here. Here is a copper sulfate is a blue in color, no, and here is the color is changed, that is called the light green in color. And iron nail is covered with the red brown layer of a copper metal, and this iron is covered with the red brown layer of a copper metal. Understand? Then I hope you will understand this paragraph. What is a displacement reaction? Okay student, let's proceed to another examples. Here many examples are given here. Other examples of a displacement reactions are zinc plus copper sulfate, okay, then it will give rise to zinc sulfate plus copper. Now students, see here zinc is written and here is a copper is written. Then again you will see the position of the zinc I have written in the previous one, that is a zinc, Fe means Sn, okay, then Pb, okay, H, then copper here. Now you will see on the top position zinc is here and copper is here. It means zinc is just above the copper in the reactivity series of a metal. And in the reactivity series of a metals are arranged in the decreasing order. Means most reactive metals are placed on the top and the least reactive metals are placed on below. Now see here zinc, it means zinc is the most reactive metal. It can easily displace the copper, okay. Then what it will give rise in the product? Zinc sulfate plus copper. means zinc can easily displace the copper. Why? Because zinc is the most reactive metals as compared to the coppers. So this is about this reaction. You will see here zinc can easily displace the copper. Okay, now another example is given here, lead plus copper chloride aqueous, that is in aqueous, and it will give rise to lead chloride plus copper. Again, when we see the reactivity series of a metal, you can just see the position of the lead. Where is the position of the lead? The students, one again, you will see here position PV is here. Okay, hydrogen, then here copper. No, you can see PB is just above the copper. It means PB is the most reactive metal as compared to the copper. Then PB can easily displace or easily remove the copper from the solution. Then in the reactant, PB is your solid in the form, copper chloride, it is aqueous solutions. Okay, then in the products you will see it will give rise to lead chloride, that is a PbCl2 plus copper. The students, you will see here most reactive metals can easily displace the least reactive metal. Then in the displacement reaction, once again I will tell you the definition of the displacement reactions. Those reactions in which one element takes place of another element in a compound are known as displacement reactions. Before writing these reactions in your copy, first of all you will memorize all the reactivity series of a metal, because in the reactivity series of metal all metals are arranged in the decreasing order. I will again tell you the most reactive metals in the reactivity series. First one is a potassium, sodium, calcium, magnesium, aluminium, tin, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver and gold. Before the copper, just below the hydrogen, all are the least reactive metals, and just above the hydrogens are the most reactive metals. Then I hope students you will understand better this displacement reactions. In the next video I will explain you about the double displacement reactions. Okay, till then you can watch this video very nicely and carefully and understand it also, and if you have any problem related to this one, you will comment me in my comment box. Till then, bye, have a nice day.